Hello everyone, my name is Faith and today I will be telling you about proving theorems on trapezoids. In this lesson, we will be stating the properties of an isosceles trapezoid with theorems that we will be discussing. We will also talk about real-life situations or objects involving trapezoids. So first, what is a trapezoid? A trapezoid is a quadrilateral with exactly one pair of opposite sides parallel. The parallel sides are called the bases and the non-parallel sides are called the legs. I have here trapezoid ABCD. Notice that segment AB and segment DC are parallel. They are what we call the bases of the trapezoid. However, segment AD and segment BC are the non-parallel sides. They are what we call the legs of the trapezoids. We also have these angles that we call the base angles. There are many theorems of trapezoid, but for this video, we will be proving 3 of those theorems. Let's start with our first theorem, Theorem 5.3. It states that a trapezoid is isosceles if and only if the base angles are congruent. Notice that this theorem is in biconditional statement form, so we will be proving 2 statements. A. If a trapezoid is isosceles, then its base angles are congruent, and B. If the base angles of a trapezoid are congruent, then it is an isosceles trapezoid. For our first statement, if a trapezoid is isosceles, then its base angles are congruent. Given ZOID is an isosceles trapezoid with congruent leg segment DC and segment IO, as you can see in the figure, prove that angle DZO is congruent to angle ZOI and angle ZDI is congruent to angle DIO. So to prove this statement, we will first extend segment ZO to point T and construct segment IT that is parallel to segment DZ. We will be using a 2-column proof for this proving. Proving is all about making connections, so if you're going to make a statement, you should always make sure that you can make another statement out of that statement. So for our proof, we have the first statement. ZOID is an isosceles trapezoid. Reason given. Second statement, segment DI is parallel to segment ZO, and segment DZ is congruent to segment IO. Reason definition of an isosceles trapezoid, which states that 2 opposite sides or the bases are parallel and the 2 other sides or the legs are of equal length. Third statement, segment DZ is parallel to segment IT. Reason by construction. Fourth statement, DZTI is a parallelogram. Reason definition of a parallelogram, meaning both pairs of opposite sides parallel to each other. Fifth statement, segment DZ is congruent to segment IT and segment TI is congruent to segment ZT. Reason opposite sides of a parallelogram are congruent. Sixth statement, segment IO is congruent to segment IT. Transitive property. Seventh statement, triangle OIT is an isosceles triangle. Reason definition of isosceles triangle, which states that if 2 sides of a triangle are congruent, then angles opposite those sides are congruent. Here are more statements and reasons that prove that angle DZO is congruent to angle ZOI and angle ZDI is congruent to angle DIO. You can pause the video to read each statement. Now for our second statement. If the base angles of a trapezoid are congruent, then it is an isosceles trapezoid. Given ZOID is a trapezoid with angle DZO congruent to angle ZOI and angle ZDI congruent to angle DIO, prove that ZOID is an isosceles trapezoid. Before proving this theorem, we will construct a segment OP that is parallel to segment ZD. So for our proving, first statement, ZOID is a trapezoid. Reason given. Second statement, angle DZO is congruent to angle ZOI and angle ZDI is congruent to angle DIO. That is also our given. Third statement, segment ZO is parallel to segment DI. Definition of a trapezoid. Fourth statement, segment ZD is parallel to segment OP. Reason by construction. Fifth statement, DZOP is a parallelogram. Reason definition of a parallelogram. Sixth statement, segment ZD is congruent to segment OP and segment DP is congruent to segment ZO. Reason, opposite sides of parallelogram are congruent. Seventh statement, angle ZDV is congruent to angle OPI. Reason, corresponding angles formed by a transversal are congruent. Our next theorem is Theorem 5.4, which states that a trapezoid is isosceles if and only if the diagonals are congruent. This theorem is another biconditional statement, so we will be proving two statements. A. If a trapezoid is isosceles, then its diagonals are congruent, and B. If the diagonals of a trapezoid are congruent, then it is an isosceles trapezoid. For the first statement, if a trapezoid is isosceles, then its diagonals are congruent. Given JAYN is an isosceles trapezoid with segment JA parallel to segment NY, prove that segment JY is congruent to segment AN. These are the diagonals of the trapezoid. Now for our proving. First statement, JAYN is an isosceles trapezoid. That is our given. Second statement, segment JN is congruent to segment AY. Reason, definition of an isosceles trapezoid. Third statement, segment JA is congruent to segment NY. Reason, definition of a trapezoid. Fourth statement, angle JNY is congruent to angle AYN. Reason, base angles of an isosceles trapezoid are congruent. Fifth statement, segment NY is congruent to segment NY. Reflexive property. Sixth statement, triangle JNY is congruent to triangle AYN. Reason, side angle side congruence postulate. Seventh statement, segment JY is congruent to segment AN. Reason, CPCTC or corresponding parts of congruent triangles are congruent. Now for our second statement. If the diagonals of a trapezoid are congruent, then it is an isosceles trapezoid. Given JAYN is a trapezoid with segment JA parallel to segment NY and segment JY congruent to segment AN, prove that JAYN is an isosceles trapezoid. Here we will construct segment AL through L parallel to segment JY intersecting NY extended at point L. Now for our proving. First statement, JAYN is an isosceles trapezoid. Reason given. Second statement, segment JN is congruent to segment AN. Reason given. Third statement, segment JA is parallel to segment NY. That is also our given. Fourth statement, construct segment AL through L parallel to segment JY intersecting segment NY extended at point L. Reason, through a point not on a given line, only one line may be drawn parallel to the given line. Fifth statement, JALY is a parallelogram. Reason, definition of a parallelogram. Sixth statement, segment JY is congruent to segment AL. Opposite sides of a parallelogram are congruent. For our last theorem, Theorem 5.5. The median of a trapezoid is parallel to the bases and equal to half the sum of the bases. In trapezoid ABCD, X and Y are the midpoints of legs AD and legs BC. Therefore, connecting these two midpoints form the median of the trapezoid. That means segment XY is the median of trapezoid ABCD. So since segment XY is the median, using the median theorem, segment AB is parallel to segment XY and is also parallel to segment DC. Also, the measurement median XY is equal to 1/2 of the sum of segment AB and segment DC. The median of a trapezoid is parallel to the bases and equal to half the sum of the bases. Given ARQS is a trapezoid with segment AR parallel to segment SQ and median LE, prove that segment LE is parallel to segment AR and segment LE is parallel to segment SQ. Median LE is equal to 1/2 of the sum of segment AR and segment SQ. Here we will draw segment SE extending until it intersects with the extension of segment AR at point N. Now for our proving. First statement, ARQS is a trapezoid. Reason given. Second statement, segment AR is parallel to segment SQ. Reason given. Third statement, LE is the median of trapezoid ARQS. That is also our given. Fourth statement, draw segment SE extending until it intersects with the extension of segment AR at point N. Reason by construction. Fifth statement, segment RE is congruent to segment EQ. Reason, midpoint of a segment forms two congruent segments. Sixth statement, angle NRE is congruent to angle SQE. Reason, alternate interior angles theorem. Lastly, real-life situations or objects involving trapezoids. I have here 3 objects shaped like a trapezoid. First is the container of the popcorn. Next is the lampshade. And lastly, the diamond on the ring. That's all for today. Thank you so much for listening, and I hope you'll have a great day.